Hey, thank you for coming my session. Today I'll talk about how to create a developer tool in Swift. You can see the talk material from the QR code. Please read this. I'll take photo of you. Thank you. Okay. Are you ready? Let's start. Yeah. Hi, I'm Giginet. I came from Japan. I work for LY Corporation. This company is known for LINE, the messaging app. I've been working as an iOS DevOps engineer for most of my last 10 years career. Currently, I'm working on the development for the fundamental layers in the LINE team. Mainly, I focus on improving the build system or developer tools for developer productivity. This is my first time visiting Korea, so I'm excited to meet with iOS community members in Korea. Today, I'll discuss creating developer tools in Swift. This talk will show you the best practices for providing useful tools for developers. The difficult point for developing developer tools is not only the technical fields such as implementation, but also finding of issues. So first, I'll introduce the developer tools that I've developed and look back on the history of tools in iOS development. It may help you to find the demands of the tools. Then, I also introduce examples of tools that make use of the Swift ecosystem and best practices. In this section, I'll mention implementation and testing. The third topic is how to improve usability. We'll discuss about documentation, deployment, and building CI flows. Finally, we will show you some tips on how to spread your tools. And let's consider about why should we contribute to the community. I hope that this talk will help you to improvement in your development environment. As a DevOps engineer, I've used development tools in my work. And I've also contributed as a maintainer of widely used open source softwares. For example, FastLane, an automation tool for mobile development. Cassage, a dependency manager for Swift. Xcode Xcode project generator. I've worked for these tools as a core contributor, and I've also contributed to the development of many other tools. As well as contributing to existing products, I also maintain some tools myself. For example, Scipio is one of my active projects. This tool builds Swift packages as XC frameworks and makes them easier to cache. It also has a remote cache backend so you can easily share build frameworks between developers. For more information, I've talked about this at several conferences in the past, so please refer to the material. By the way, Scipio is the name of a historical Roman general who destroyed Carthage. See details for the history books. And another tool I recently developed is Swift Testing Revolutionary. This tool automatically converts existing XC test cases into Swift testing cases. It can easily integrate into Xcode projects as Swift packages. If you are interested in using Swift testing, I'm glad to try it. As I showed, I've developed various tools during my career. Now, let's learn about the basics of tool development and how developer tools can improve your team's productivity. Even if you are interested in development tools or DevOps field, you might feel creating tools would be difficult. The first question that will probably come to mind is what kind of tool you should create. In addition, you might also be wondering, how should we develop them? How can we spread them? Should we make it open source? In this talk, I'd like to answer these questions. First, let's look back what tools the iOS community has developed and improved to learn about developer tools. Looking back over the past 15 years or so, in my view, the history of the iOS community can be divided into three major eras. First, the prehistoric period before the birth of Swift in 2014. The dawn of Swift community. And it was after 2019 that Swift Package Manager became widely used. In the old days, after the birth of iOS, it was difficult to use Objective-C for anything other than apps. So the tool development was difficult. At this time, the Ruby development culture was often brought into the iOS world. One of the most early appeared popular tools is Cocoa. Other tools such as FastLane, the CI tool Danger, or log format Xplicity are still being used and maintained. All of these tools are written in Ruby, but the number of developers who have knowledge of both Ruby and iOS is decreasing. After Swift was released in 2014, many tools appeared in Swift. These development tools are still widely used today, such as the Package Manager Carthage, SwiftLint, and Xcode. At that time, however, the development infrastructure for tools was not yet in place. There were many implementations of argument parsers and test frameworks, and distribution was also difficult. In 2019, since Swift Package Manager was integrated in Xcode, Apple and the Swift community have been working to standardize the tool development environment. Today, we have many useful foundations such as Swift Argument Parser or Swift Testing. That's right. It's become much easier to develop tools in Swift. As you can see, it's now easy to get started with tool development. However, what should we develop? It is the most difficult topic. As we can see, many problems have been solved using famous developer tools and existing tools. Is it necessary to create new ones? So I recommended that you first develop a tool for your team. Do not aim to solve the problems of someone. Let's solve the issues of your teams by tool development. Our team develops writing tools for our developers. Let's see the tool for a practical example to improve developer productivity. This tool provides many features. First, a build task for external dependencies. It resolves dependencies, builds XC frameworks, or downloads pre-built frameworks. This tool is developed based on Scipio. We published the core implementation as an open source, and we extended this to meet our requirements. The second example, we provide task runner for pre-built tasks. For example, our project uses Xcode Gen to generate Xcode projects. We develop a tool to run the generator or to verify their specs. The third example is CI scripts. We developed the workflow to generate test plan for each pull request. It generates test plans by file diffs in pull requests. For such a use case, we have to implement complex logic like network request to GitHub API. This is a good case to use Swift rather than other script languages. The last case is extending Xcode features. We develop linters to verify company coding rules for developers. We use Swift syntax to create this tool. As seen, by writing tools in Swift, you can also make use of the language development foundation, like Swift syntax. This way, we can receive many benefits by developing tools in Swift. First of all, we do not need to run any other languages. We can use only Swift. Additionally, we can use powerful language features like Swift concurrency. Others, it helps to improve future maintainability, such as through type safety. So far, We have looked at practical examples of developer tools. From here, let's develop tools in practice. We need to learn the various basic techniques for good tools. Let's look into the description of the tool I developed. First, testing and building CI is fundamental. Documentation is also important. We also need to think about how to distribute these tools. Finally, sometimes we need to keep backward compatibility. Like this, there are many required techniques for tool development. Learning them helps to develop not only for open source tools, but for your in-house tools. First, before the development, let's choose the kind of tools. Mainly, we have two options, executables and package plugins. Executable is a regular command which has a command line interfaces. We can develop almost any tool, but it's a bit difficult to distribute them. The second option is package plugin. It has been introduced since Swift 5.6. Thanks to this feature, we can distribute easily or provide graphical interfaces on Xcode. There are two types of package plugins, build tool plugin and command plugin. Build tools plugin can provide the build hook in the build processes with Swift Package Manager. For example, code generations are a good example for pre-built plugins. On another front, post-build tools are good for formatter or linters. In fact, Swift Lint or Swift Format also provides plugins. On the other hand, command plugin can provide commands that users can execute anytime. Using this, we can distribute CLI tools easily. In addition, we can also provide a graphical user interface for Xcode. For example, my tool, Swift Testing Revolutionary, is also provided as a command plugin. So you can convert your test cases on Xcode. However, I feel the package plugin is not yet a useful feature. As far as I've used it, this function seems to be broken sometimes. See the WWDC session for details. After choosing the types of your product, let's begin to implement. When creating developer tools in Swift, one essential library is Swift Argument Parser. This library passes argument from the command line and provides an entry point for executing commands. Similar mechanisms are provided in standard libraries for other languages. As I mentioned, Swift Argument Parser is currently the standard choice. As seen, we can declare the command line arguments with the DSL like flag, option, or argument. After the declaration of options, we can implement logic in the run method. You will use this library for any tools. For the tiny tools, it's enough that you can implement logic in the methods. However, for complex tools, it's better to make your product to be multi-modules. I often adapt the following architecture. It's better to extract core implementations into the other module. This is because it can be tested. It's difficult to write unit tests for executable targets. So extracting the implementation to the external targets helps to write unit tests. The second benefit is that we can minimize dependencies. In this case, Swift argument parser should depend only on the executable target. This way, we can reduce dependencies as much as possible. All that remains is to implement your tools. The implementation will be different depending on what you develop. So there is nothing to say here. I believe you can implement your tools by now. Let's develop tools. Let's time to develop tools. From now, I'll show tips on how to spread your tools to many developers. First, documentation is essential. Making README is the first step in getting good documentation. When I create a README, I always keep the following points in mind. First of all, I put a lot of batches in a row. This is because I feel that tools with a lot of batches looks more reliable. I often use shields.io to create batches. Next, it's better to mention how to install it. Unfortunately, there are no standard ways of distributing Swift tools. I'll explain how to distribute tools later. I also try to write feature lists. This is useful for communicating to users about the limitations of the roadmaps. And if you release your tools as open source, don't forget to clarify the license. You can also distribute the doxy. I recommend writing a doxy article in addition to the API reference. You can provide a more readable guide written in Markdown. We can use the Swift Doxy plugin and GitHub pages to publish Doxy page. Preparing a following pipeline, you can keep your documentation up to date as you update your tools. I also recommend adding your tools to the Swift package index. This will make tools more findable to other developers. Additionally, it automatically generates the doxy page and checks compatibilities. We can easily request to be listed. Finally, let's take a look at the distribution of tools. There are various methods for distributing tools created in Swift, but there is no standard method yet. The easiest way to distribute is to ask users to build it by themselves. The advantage of this method is that we don't have to do anything. However, there are a few ways to manage installed binaries for users. A well-known method is to use Mint. However, Mint doesn't provide the feature to manage pre-built binaries. So each user has to build tools by themselves. This way is not very efficient because they need to be rebuilt every time there is an update. So we are focusing on distributing using artifact bundle. This is the Apple official executable distribution format. This is the format for distributing binaries for multiple platforms in a single zip file. This makes it possible to distribute pre-built binaries for x86-64 and ARM64. However, there are many issues using artifact bundle. The first is it's difficult to create it. To solve this, we use artifact bundle gen. This is a tool for creating a zip file that follows the artifact bundle format from pre-built binaries. Author of this tool is Aki-san, also as known Freddy. He is also the speaker on this conference. He will talk in this evening about Xcode 16. There is also the issue that it's difficult to run artifact bundles as standalone binaries. One of our team members has also developed a tool called Nest. This tool is an evolution of Mint. If artifact bundles are published on GitHub releases, this tool will download them without building them. Please give it a try. As seen here, we are finding efficient ways to distribute binaries. Finally, I'll explain the automation through CI. Some tasks I explained should be automated. They are like running tests, executing linters, update documents, or distributing binaries. We can automate these processes by only using GitHub Action. I often make separate workflows to do them. This is an example to define the workflow to run the tests. With this setting, we can easily make pull request builders and run them for multiple versions of Xcode. I've talked about how to promote the tools so far. I first said that there is no need to force them to become open source. Let's begin to develop for your team first. However, if possible, I'd like you to consider making them open source. Why should we publish your tools? For the most motivated point, making your tools public can help improve your presence and career within the community. What's more, it will give contributions or inspirations to the communities. On the other hand, let's also consider the benefits you get from publishing tools. You can receive feedbacks and improvements for the tool from the community. This will also motivate you to continue improving your tools. By releasing our tools, we are also able to receive bug reports and feature additions from other developers. For example, by releasing the core of our build system as Scipio, we could receive many feature additions and collaborations. On the other hand, if you are just thinking about releasing a tool, it won't work. If it's not designed for your team, it will be difficult to improve the tool's usability or keep the motivation to maintain it. To make a tool to be great, we need both your team's use and the community's contribution. It's time to conclude. First, finding the issue is the most important topic to create tools. Then, I talked about how to create tools with modern techniques. I'm so glad if you contribute to the community by developing your tools. If you want to know the details, please refer to my products on my GitHub. And feel free to ask me anything on X or Ask the Speaker booth. I hope to talk with you. I welcome you to come to my Ask the Speaker booth. Ask me anything. Okay, that's all. Enjoy this great conference. Thank you for your time. ありがとうございました。